As usual, to deal with this limit, we do a direct substitution, and if you substitute by -4 for x, then you will see that the numerator is going to go to 0. The denominator will also go to 0, and this is indeterminate, and we have to do something about it. It is easier to pull things outside the square root, so the limit could be written as the limit as x goes to -4 of the absolute value of x plus 3. And this is very important because you understand that the square root of w squared is not simply w, because w could be negative, so it's just the absolute value of w. So the square root of x plus 3 squared comes out of the square root, becomes the absolute value of x plus 3 minus 1 divided by x plus 4. Now you realize that x plus 3 as x goes to -4 is going to be negative. Alright, so therefore, in order to release the absolute value, we have to multiply what's inside by a minus sign. So that's going to be the limit as x goes to -4 of minus whatever is inside, which is x plus 3 minus 1 divided by x plus 4, which should be easy to see that it can be written as minus x minus 4 divided by x plus 4, which when you pull a minus 1 out will result in a minus x plus 4, and this is also x plus 4. You can cancel x plus 4 because x is not exactly -4, but is going to -4, so the result is just -1. As usual, substituting x equals 0 into this expression will result in 4 power -1 minus 4 power -1 divided by 0, and the numerator is also 0, so this is 0 over 0, which is indeterminate. So we try to rewrite this expression in a different way. So if you write 4 plus x power -1 as 1 over 4 plus x, and also the same thing for 4 power -1, and you try to now take a common denominator in the numerator. Okay, so what happens is that you get 4 multiplied by 4 plus x, and then goes here 4 minus 4 plus x divided by x. So this is equal to the limit is as x goes to 0 of now in the numerator you get actually 4 minus 4, which is 0, and you get a minus x here, and this is 4 multiplied by 4 plus x divided by x. So x is not 0, it's just going to 0, approaching 0, so you can cancel this out, and then the result is going to be the limit as x goes to 0 of -1 over 4 multiplied by 4 plus x, and as x goes to 0, this is going to go to -1 over 16. Okay, for this limit, a direct substitution will result in 2 over 2 times 1/2, which is 1 minus 1, minus 3 divided by 2 multiplied by 1/2 square, which is 1 over 4, plus 1/2 minus 1. So that goes to 2 over 0 minus 3 over 0. Well, we actually don't know whether this 0 is, we're coming to this 0 from the left or right, and also this 0 we're coming to left or from right. So this needs a bit of further investigation. And the way that we do it is that we take the limit as x goes to 1/2 from the left of the function, whatever the function is now here. So that's the okay, let's just do a direct substitution now. So this is going to go to 2 divided by 2 times 1/2 from the left, so that will become 1 from the left, minus 1, and then minus 3, 2 times 1/2 from the left, which means 1 over 4 from the left, plus 1/2 from the left minus 1. What that means is that this is going to go to 2 over 0 from the left, because this is 1 from the left minus solid 1, and minus 3, and if you see this here, the whole expression, this is 1 from the left minus 1, so this also results into 0 from the left. So this is 3 over 0 from the left, and 2 over 0 from the left is minus infinity, and this is also minus infinity, but we have this minus infinity, so this is a plus infinity. You may as well want to try this from the right. As x goes to 1/2 from the right, you will see more or less the same thing, infinity minus infinity, and we know that infinity minus infinity or minus infinity plus infinity, which is the same thing, is indeterminate, and we need to do something about it in order to understand what this limit is. So one way to deal with this limit is just to combine terms. So this is the limit as x goes to 1/2, and this is a 2 over 2x minus 1 minus, if you factor this expression, this is going to result in the second expression into 2x minus 1 multiplied by x, 2x minus 1 multiplied by x plus 1. Now it's time to combine these two terms together by taking a common denominator, which is 2x minus 1 multiplied by x plus 1, and the numerator here is going to go like 2 times x plus 1, and that's only minus 3. Okay, simplifying this expression further, so this is the limit as x goes to 1/2 of 2x plus 2 and minus 3 is going to go like 2x minus 1. The denominator is also 2x minus 1 multiplied by x plus 1. You can also use parentheses here. Now it's time to cancel 2x minus 1 with 2x minus 1, because that is not 0. And that is approaching 0 but not exactly 0. And if you substitute by x equal to 1/2, you get 1 over 1/2 plus 1, which is 3 over 2, and the result is going to be 2/3. Okay, a direct substitution for this limit will result in 0 over 0, which is indeterminate. So what can we do about this? Is that we, since that expression contains square roots, we'll probably multiplying by the conjugates is a choice. So that limit is going to be equal to the limit as x goes to 1. This is the square root of x minus x squared divided by 1 minus square root of x, and I'm going to multiply by the conjugate of the denominator, which is 1 plus square root of x, and I also multiply up here by 1 plus square root of x, so that expression here is just 1, and as if you multiply by 1 and you don't do anything serious to the expression. Okay, so if you evaluate that, that becomes the limit as x goes to 1 of the square root of x minus x squared divided by, multiply these together, what you get is 1 minus x, and we have this 1 plus square root of x there, and I use parentheses to avoid mistakes. Okay, now if you let x go to 1, this will still result in 0 over 0, and possibly we can do something about the expression by multiplying also by its conjugate. So this is going to go like the limit as x goes to 1 of the square root of x minus x squared divided by 1 minus x, and multiply that by the square root of x plus x squared and divide by the same thing, so that's equal to 1. Yes. And then we still have to get this expression down, which is 1 plus the square root of x. Now the multiplying these two together will result in, of course, the limit as x goes to 1 in x minus x power 4 divided by 1 minus x, and we have 1 plus square root of x. Up and down we have the square root of x plus x squared. Now if you pull x from x minus x to the 4, then you see that results in 1 minus x cubed divided by 1 minus x, that is 1 plus the square root of x divided by the square root of x plus x squared, and that is the limit as x goes to 1, and I will factor 1 minus x cubed as the difference of two cubes, so that is 1 minus x multiplied 1 plus x squared. This is a standard factorization. Okay, divided by 1 minus x, and I will use parentheses here, multiplied 1 plus the square root of x divided by the square root of x plus x squared. Okay, so there's a bit of cancellation that takes place here. So 1 minus x will go with 1 minus x for the same reasons we've been saying for so long. So that's the limit as x goes to 1 of x multiplied by 1 plus x squared divided by the square root of x plus x squared multiplied by 1 plus square root of x here. So now as x goes to 1, this is going to 3. Okay, that's 3 divided by 2 multiplied by 2, and the result is just 3.